Okay, let's look at our percent yield notes. Percent yield is at the bottom of our stoichiometry cheat sheet. So percent yield, it's our actual yield over our theoretical yield. So we'll go over that in a minute. So really the percent yield is a ratio that tells you how efficient a chemical reaction is. So the higher the percent yield, the more efficient the reaction is. So the better you perform the reaction, okay? So the actual goes on top. That's your experimental. I did a reaction in an experiment and I got this amount. How much should I have gotten is the theoretical times 100, okay? And I have that on here. What you got in the lab over what you calculated you should have gotten in the lab times 100. That's going to give us our percent. All right, so right here, the actual yield is the one you got in the experiment, and the theoretical is the one you are ideally supposed to get if everything goes perfectly in your lab. And you can calculate that amount using stoichiometry, okay? And they're all mass to mass problems, okay? I made it easy for you by giving you all mass problems, all right? So here, a student reacts 40 grams of hydrogen with an excess of oxygen and produces 300 grams of water. What's the percent yield? Okay, so it's telling us this person did a lab and produced 300 grams of water, okay? That's what they got in the lab, okay? But what should they have gotten? You're going to calculate the theoretical yields. So it's going to do a mass conversion, starting with the given reactant and converting to the product, okay? So here, what do we know? We've got 40 grams of hydrogen, so that's going to be our X. And what do we want to know? How many grams of water are we going to produce theoretically in the lab? Okay, so we're going to do a mass problem. And again, use your cheat sheet. You've done these before. What do we measure mass in? It's grams, so it's a grams to grams, mass to mass. All right, so we're going to start with 40 grams of hydrogen gas. And we're going to convert grams of hydrogen to moles of hydrogen, okay? That's exactly what it says to do here on our cheat sheet. We got 1 mole over molar mass, okay? So what's the mass of hydrogen? 1, and there's 2 of them, so I got 2 grams here, 1 mole, okay? So I got grams to cancel. Now I've got moles of hydrogen on the bottom, and I'm converting to moles of what? Water. So this is where I'm going to use that coefficient of Y over the coefficient of X, or what we call the mole ratio. So in front of water I have a 2. In front of hydrogen I have a 2. So that's good. Those will cancel out, right? And then I've got to convert what? I've got to convert moles back to grams by using molar mass of Y over 1 mole of Y. So water, H2O, I've got 1 oxygen plus 2 hydrogen, that's 18, so I'm going to have 18 grams of water over 1 mole. All right, now I'm ready to calculate, right? What else cancels out here? We got 1 mole, 1 mole. Those are going to cancel out. And so basically what am I left with? 40 times 18 divided by 2. So 40 times 18, enter, and I'm going to divide by 2, and what I get, 360 grams of water is my theoretical yield. Okay, let's go back to here. We're going to calculate that percent yield, and it says right here we're going to take the actual yield from the lab, and we know back here that this student got 300 grams of water in their lab theoretically, the student should have gotten 360. All right, so we're going to do a division problem, then multiply by 100 because this is a percent. So we've got 300 divided by 360 times 100. Oops, I didn't put in times, did I? Delete. Times 100. And there we go, 83.33. 33 what? Percent. That's how well you performed your experiment. Okay? So, when we flip over to the other side to do this, we're going to do the same thing here. We're going to practice doing these reactions. Okay, so this time it says we have 11 grams of this N2H4. So that's what I know. 11 grams with excess of, this is hydrogen peroxide. We're going to cancel that out. I don't need to know that. And we're going to yield 35 grams of this nitric acid. Okay, so this is the Y. What do I know? I've got N2H4. So this is my X. And again, we're going to do a mass-mass conversion. Okay, so right here we've got our X and Y. Mine says water. It should be this HNO3. Okay, so we're going to start with 11 grams of N2H4. I'm going to convert grams of N2H4 to 1 mole of N2H4. Okay, so 2 nitrogen is 28 plus 4. So that would be 32 grams. That's my molar mass. Then I need moles of N2H4. And what's my Y? HNO3. So it's a 2 to 1 ratio. And then I need my molar mass of HNO3 over 1 mole of HNO3. So what's my grams? I've got hydrogen's 1, nitrogen 1, oxygen 3. So 48 plus 14 plus 1, 12, 13, 4, 5, 6, 63 grams. All right, we're ready to calculate. These will cancel out. So we're going to do 11 times 2 times 63. And then on the bottom, we've just got 32 because there's a 1 there. So we're going to divide that by 32. And so what do we get? We get 43.3125 grams of HNO3, which is nitric acid. What's actually produced is 35 grams of nitric acid over what you theoretically produced times 100. So we've got, what did I say, 35 divided by this 43.3125 times 100. So there's our answer, 80.81. And again, it's a percent. So there's my percent yield. Okay, so you're going to do that over here on this first one. It's already giving you the theoretical, so you're just going to take the actual divided by the theoretical times 100. But here on 2 and 3, we're going to do these mass problems. Okay, and the percent yield problems. And let me know if you have any problems with those.